All right, this is section 6.4. I'm going to talk about rectangles and squares. Both of these shapes I'm sure you have seen before. So now let's take a look at like all the specific details as far as segment measures and angle measures that we might find or be trying to find when we're working with rectangles and squares. So first of all, I have a rectangle here drawn. So you may want to grab a sheet of paper and draw yourself a rectangle. A rectangle is a parallelogram, so all the properties of a parallelogram will still be true in a rectangle. So, for example, in a parallelogram, we have opposite sides parallel. You can still see that is true here. The top is parallel to the bottom, left side parallel to the right side. All right. One of the other properties of a parallelogram is that opposite sides are congruent. So for example, I'm going to make up some numbers here. Let's say the top of my rectangle is 8 centimeters. That means the bottom of my rectangle will also be 8 centimeters. If the side of my rectangle, let's say left side is, I don't know, let's go 3.4 centimeters. Right side would also be 3.4 centimeters. Okay, so again, that is the same as a parallelogram. The one thing that you probably notice about a rectangle that makes it look quite a bit different from a parallelogram is the angles that we see in the corners here. Okay, so in a rectangle, the main thing that makes a difference from a parallelogram is that now you have 4 right angles. All right, so in my rectangle, we have 90-degree corner here, 90 degrees in the corner there, 90-degree corner there, and 90-degree corner there. All right. If you think about, again, when we were looking at angles in a parallelogram, we talked about opposite angles are congruent. So you can still see that, again, that's still true. We got 90 there, we have 90 there. And then we also talked about that the consecutive angles were 180. And again, still true, 90, 90. Okay. So again, like I said, all the parallelogram properties are still true. All right. In addition to that, now we have 4 right angles. All right. So that's kind of what it looks like. I'm going to go ahead and draw the diagonals so you can kind of see what happens once we start getting more information in our rectangle. All right. So one of the properties of a parallelogram was that the diagonals bisect each other. Okay, again, which means divides each diagonal into equal halves. All right. Now in a rectangle, we also know that the diagonals are now congruent. Okay, this did not happen before. Okay, but it will happen whenever you have a rectangle. The diagonals are congruent. So if we combine that with the idea that we know the diagonals bisect each other, that would mean that, again, I'm just kind of making up numbers here. Let's say this one is 4.4 from there to the center. Since it's bisected, we know this would also be 4.4. All right, all the way across the diagonal then, we would have 8.8. All right. In a rectangle, the diagonals are congruent, so that means this diagonal must also be 8.8. And again, since it's bisected, we know we still have 4.4. So when you have a rectangle, you know that those 4 pieces kind of all going to the center will be the same length. So whenever I'm working with a rectangle, I always kind of like to put my little marks on there. I'm going to put my little dash, Okay, so all 4 of these segments going into the center, when you have a rectangle, will be the same length. All right. Now, if you're looking at the rectangle, hopefully you're noticing some triangles in there when we drew our diagonals. And if you look at some of those little marks that I drew, you'll also notice that these triangles are isosceles triangles. All right, which is going to help us when we start looking at or trying to find different angle measures. All right, So I'm going to give you an angle measure, and then we're going to kind of see what happens with some of the angles. So let's say I'm going to go with 22 degrees. Okay, and that angle right there in the corner. Now, one thing that I can figure out right away before I go any farther, we already know the corner was 90 degrees, and I just told you that this part of the corner was 22. So if together they have to equal 90, if I take 90 and subtract my 22, I can find this measure right next to it, which would be 68 degrees. Okay, so the 68 plus the 22 has to equal the 90 degrees in the corner. All right. Now, using triangles, alternate angles, and things like that, we can pretty much figure out all the rest of the angles in this figure. All right. So first of all, this, like I said, is an isosceles triangle. So if this angle is 22, this angle right here would also be 22. Those would be our base angles, and they always have to be the same because it's isosceles. All right. Similar to what we did in this corner, we know the whole corner is 90. I use 22 degrees of that 90. That means this angle here must also be 68. All right. If I use my alternate angles, so again, alternate interior, the ones that look like the Z. So if you kind of follow through the Z here, it goes across. Okay. So if this one is 22, I know this one up here would be 22 as well. Okay, those are alternate interior. Since this triangle upside down is also isosceles, very much like this one, if this is 22, this would be 22 as well. So you can kind of think of taking this triangle and just flipping it back up top. And then to find the other ones that I'm missing here, again, same thing with the 90 in the corner. We use 22. This has to be 68 degrees. This one over here would also be 68 degrees. So if you kind of take a look at what's going on in the corners, you'll notice that each corner was 90, and in this case divided into a 22 degrees and a 68 degrees. When you look at the triangles, again, those base angles next to each other should be 22s there. This is also an isosceles triangle. You can see we have 68 and 68 there as well. All right. And that's kind of always the way the rectangle is going to look because of that 90 degrees in the corner and because of the fact that you have those isosceles triangles. Now, right now, I do not have the angle measures in the middle. However, if we go back to our triangle information, we know that the three angles in a triangle always have to equal 180. So if I pick whichever one of these triangles I want to start with, I'm going to start with kind of this one on the bottom here. We have 180 degrees for the entire triangle, and we see that we already have two of the corners were both 22. So if I went 180 minus 22 minus 22, that means this angle right here in the center would have to be 136. All right. If I wanted to find out the rest of the angles in the center there, we could do things like our vertical angles. So if this is 136, this would be 136 as well. We could do a linear pair to find this one, or if I wanted to, I could go back to one of these other triangles here. Okay, but if that's 136, if I were to go 180 minus 136, this angle here would be 44. And again, 44 here as well, using my verticals. Or again, if you wanted to, you could check this triangle here. 68 plus 44 would equal 180 as well. All right, so again, once you have the diagonals in there, you have lots of other things to choose from as far as how you find the other measurements you're looking for. Triangles, vertical angles, alternate angles, all those sorts of things. All right. All right, that pretty much sums up the rectangle. The square, again, pretty sure you're familiar with the square. Looks something like that. I have one drawn. So again, if you want to grab a straight edge or a ruler, draw yourself a little square. Let's talk about what's going on here. Again, a square still is a parallelogram. So like we talked about with the rectangle, all the things for the parallelogram will still be true here when we look at it. All right. Probably one of the things you do remember about a square, okay, you'll notice it does look somewhat similar to the rectangle, and that is because in a square you will also have those 4 right angles in each of the corners. All right, so we have 90 degrees there, 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 and there. All right. The other thing that you probably recall about a square is that it also has 4 congruent sides. All right. So again, if I'm going to make up some measurements here, let's just go, I'm going to say 6 centimeters, 6 centimeters, 6 centimeters, and 6 centimeters. All right. Okay, let's go ahead and let's get our diagonals in here. All right. So a square is going to have some things similar to the rectangle, like we talked about here, and a square also has some things similar to a rhombus, which is what we talked about the other day. Rhombus has 4 congruent sides. Square also has 4 congruent sides. So it's kind of a combination of both the rhombus and the rectangle. All right. If you look at the square that I have drawn here, we will find out, or we know, that the diagonals are going to be perpendicular. So like I said, it is similar to a rhombus, and in a rhombus we knew that the diagonals were perpendicular. In a square, they will be perpendicular as well. Okay, so that means right now I could go ahead and I have 90 degrees at all 4 of these angles in the center. All right, and you'll notice again, this looked a lot different in the rectangle. So we do not have 90 in the center of a rectangle. We do have 90s in the center of our square. All right. In a square, the diagonals are also going to be congruent. Okay. So again, whatever this diagonal is going all the way across here would have to be the same as the diagonal going across this way. All right. And since they bisect each other, again, whatever one half is, then we know the other half would be the same. So if this is 4.2 centimeters, this would be 4.2 centimeters there. 4.2 centimeters to the center there, 4.2 centimeters on the other half. All right. And then the last thing as far as the square, the angles in a square are pretty easy to figure out, definitely not as complicated as the rectangle, because in a square, the diagonals bisect the angles in the corner. All right. So what that means is we knew we had 90 degrees in the corner when we started, and if the diagonal bisects that, that means every angle is going to be 45. Okay, so every time you have a square, it will look like that. 90s always in the center, 90s for the entire full corners, and then every 90 degrees is split into 45 degrees. And that is your square.